हरि करना।
Welcome to the second part of seventh module, static code analysis with SonarQube. So in the previous part of this seventh module, that's part 1 of seventh module, we looked at how to test the functionality of an API with Postman, and we have looked into the Postman in totality. A Postman is a free tool for working with API and for testing APIs. And also we have looked into the integration and automation of these tests in a CI/CD pipeline using Newman. So we have discussed about that. Then, testing the functionality of an API or application is good practice when we wish to improve the quality of applications. In a company, the quality of an application must be considered by all its members because an application that brings business value to users increases the company's profits. However, we often neglect to test the quality of the code because we think that what matters is how the application works and not how it is coded. So this way of thinking is a big mistake because poorly written code can contain security vulnerabilities and can also cause performance problems. Moreover, the quality of the code has an impact on its maintenance and scalability because code that is too complex or poorly written is difficult to maintain and therefore will cost more for the company to fix it, to maintain it. In this part of 7th module, we will focus on static code analysis with a well-known tool called SonarQube. We will provide a brief overview of it and we will go over and we will install the SonarQube. Then we will use SonarLint to analyze the code locally, and finally we will integrate SonarQube into a CI/CD pipeline using Jenkins and Amazon Web Services. We will do that in our mega project. I'll show you how to do that. So we'll have one project of SonarQube. So that we'll do. In addition to that, SonarQube will be used in our mega projects also. So, but the question arises, what is SonarQube? SonarQube is a self-managed automatic code review tool that systematically helps you deliver clean code. So clean code is pretty important. That if you provide a clean code to the system, so the system can understand the code better than that the code with a lot of lot of scrap, lot of nonsense inside the lines, in between the lines, in between the lines. There, if you keep a lot of spaces, so this is like you're complicating the things around. If you complicate the things around, the machine has to spend more amount of time, and after that, even if you want to debug it, if you want to solve the some problem, if you want to find an issue, if you want to maintain it, it's going to take huge amount of resources. It could be money, or it could be time, or it could be man force. So a clean code is very important as a core element of this Sonar solution. Sonar Cube integrates into your existing workflow and detects issues in your code to help you perform continuous code inspections of your project. So we are going to do one project in this. So that project is, so we will be adding this Sonar Cube into the continuous integration pipeline. So as every time the code is being pushed into the repository, and then the pipeline will be triggered. Once the pipeline will be triggered, our Sonar Cube comes into the picture, and it will automatically do the analysis, code analysis. And once the code analysis is done, it will show you the errors, how many bugs are there, how many errors are there, and how many issues it has found. So everything it will show, how many vulnerabilities are found. So it will show everything. So that kind of project we are going to do. So then the total, so it can integrate 30 plus different programming languages with it, and it can also works with CI pipelines and DevOps platform. That's the fantastic feature of SonarQube. So because of that, most of the people are using SonarQube. It doesn't mean they're not using other tools. They use other tool also based on the requirement. So now, writing a clean code. How to write a clean code? What's clean code? Writing clean code is essential to maintaining a healthy code base. What does healthy code base? Healthy code base, if you have a clean code, so you can have the proper healthy code base. So we define clean code as a code that meets a certain defined standard. That's code that is reliable. The first parameter under that is the code that is reliable, the code that is secure, the code that is maintainable, the code that is readable, and the code that is modular. So this is called as a clean code. In addition to having other key attributes, this applies to all code, source code or test code or infrastructure as a code or glue code or scripts, whatever it may be. As a DevOps guy and MLOps guy, you might have been writing plenty of scripts or plenty of codes. So it may be a source code, it may be a test code or test script. We have done it in Postman. Similarly, you can use some other tool to write a script, and you can write an infrastructure as a code. We have done it in Terraform, Packer, Ansible. You just go back and visit those videos. Nothing wrong. Just learning is nothing wrong. I keep on learning every day, every minute, every second I learn. What's wrong? Nothing wrong. Just go and watch and come back again. Nothing wrong. Learning is not at all a wrong thing. So, and similarly, we can have a glue code and scripts. It could be anything, but the code should be clean. Code should be modularized. Like if you have written the Python code, in spite of putting all thousand lines of pieces of codes into single file, a single .py extension file, you create a nice directory. Inside the directory, if you want to write a different modules, write a different modules and put the directory name as a modules, and inside that you keep all this module files, module 1.py, module 2.py, module 3.py, and then you take only one main.py, and connect all those modules with this main.py. See how nice it is, how beautiful it is. It looks more beautiful than your girlfriend if you write like that. Sometimes you may feel that coding is much, that whatever you have written, if you write like this, if you write a clean code, so clean code is beautiful than your girlfriend or your boyfriend, handsome than your boyfriend. Okay, that's fine. So that's what the clean code is. So now sonar's a clean sonar's clean as a code approach so eliminates many of the pitfalls that arise from reviewing code at a late stage in the development process. The clean as you code approach uses your quality gate. This is very important. We are going to do this. We are going to including this in a project to alert or inform you when there is something to fix or review in your new code or the code that has been added or changed. New code here means, or new code, I mean the code that has been recently added or changed or pushed or committed. So allowing you to maintain high standards and focus on code quality. So here the concept of quality gate is nothing but, so you can set up, okay, if the new code that has been added, if it brings 5 bugs and 2 vulnerabilities, it has to alarm, it has to make an alarm that so it has crossed the threshold. Then immediately the quality gate says it's failed, the quality gate fails, so then the next step won't be executed. So in that way this will be useful, this will be very much useful in our pipelines or MLOps pipelines or DevOps pipelines. Developing with Sonar. The Sonar solution performs checks at every stage of the development process. We have SonarLint. SonarLint provides immediate feedback in your IDE as you write a code, so you can find and fix issues before a commit. So here what we are discussing is, we are discussing the ecosystem of Sonar to save us from the bugs and vulnerabilities. In other way, the ecosystem of Sonar which can assist and support us to write a clean code, clean, okay, clean, a modular, a clean, a reliable, clean, a readable. Clean means a secure, clean means a maintainable. So a maintainable, readable, reliable, secure, and modular. So this kind of code can be written to make that is possible. Sonar provides a complete ecosystem. So the first one in that ecosystem is SonarLint. So SonarLint provides immediate feedback in your IDE as you write code, so you can find and fix issues before a commit. So then we have SonarQube's PR analysis that fits into your CI/CD workflows with SonarQube's PR analysis and use of quality gates. So then we have quality gates concept. The quality gates keep code with issues from being released to production. That's the main thing. We use this quality gate concept in the pipelines, in the CI/CD pipelines of DevOps or MLOps. Okay, so this quality gates keep code with issues from being released to production. A key tool in helping you incorporate the clean as you code methodology. So then the clean as you code concept of Sonar approach helps you focus on submitting new clean code for production, knowing that your existing code will be improved over time. So organization starts off with a default set of rules and metrics called Sonar Way Quality Profile. This can be customized per project, and then this can be customized per project to satisfy different technical requirements. Issues arised in the analysis are compared against the conditions defined in the quality profile to establish your quality gate. Then a quality gate is an indicator of code quality that can be configured to give a go or a no-go signal on the current release worthiness of the code. It indicates whether your code is clean and can move forward, or so what's the representation of it, how it designates a passing green, you see that a passing green here, a passing green quality gate means that code meets your standards and is ready to be merged, and a failing ready to be merged, do you see that? Okay, if it is a failed one, a failing red quality gate means that there are issues to address, then immediately it will get back to the initial IDE, it will go back to the IDE. So SonarQube provides a feedback through its UI, email, and in decorations or on pull or merge requests to notify your team that there are issues to address. Feedback can also be obtained in SonarLint supported IDEs when running in connected mode. So SonarQube also provides in-depth guidance on the issues, telling you why each issue is a problem and how to fix it, adding a valuable layer of education for developers of all experience levels. Developers can then address issues effectively. So code is only promoted when the code is clean and passes the quality gate. On the other side, if quality gate passes with a green light, so with a green symbolism, so it will go further, it will go for the merge and promote, and it will finally get into the production ready so that it can be exposed to the external world. So let me repeat it one more time quickly, a quick a cycle of SonarQube ecosystem. So it begins with uh, it begins with the IDE. That's where the coders, the developers begin. So the code has been pushed, and after that, so it will be committed, and then after the commit been pushed, and once it's pushed, it's time to build and test it. We'll use different kind of tools. So all will be used and then built and tested. Once it is done, then it goes for the source code analysis. That's a source code analysis. So there we'll set up, okay, you check it. If it crosses this many bugs and this many vulnerabilities, you just raise a red flag. So initially it's a red flag. So as it is a red flag, now it will get back to the developers. So developers will look into that and see, okay, that's the issue. So now it's time to check it. But if you want to effectively and efficiently check that, you need the code should be clean. CLEAN, clean. Okay, what is clean? You should know by this time. Okay, so that's one case. And another case, if the gate was passed, if the gate is passed, the quality gate is passed, and the green, the symbolism will be in green, so then it will be merged and promoted to the higher stage. So where once it is ready, then it will be packaged and then it will be moved to the production, into the production server. Hence it is production ready. So now it will be accessed by the users.